Okay, in example 2, we're graph a transformed square root function. So here's our square root, and we identify the domain range, just like we did in the last video, and then describe how it's related to the parent function. Well, the parent function, we're talking about square root, so the parent function would just be f of x, or y equals square root x, right? So that just looks like at 0, 0, and it goes up from there like that. So we're describing how this one's a little bit different. Okay, so we notice that to make the square root 0, we set the inside of the root to 0, and we saw when we get x equals -1, right? So that means we're a little bit left from this parent function, right? We're going to start at -1 instead of we're going to start at -1 instead of at 0 on our x. Now for our y value, we look at this outside, what we're adding to on the outside. So that means our y is going to be 2, correct? So that means we're going to be up 2 and we're left 1. So instead of starting down here at 0, 0, we're now at -1, -1, 2, right? So that's how it kind of changes. Now we notice that we have this -3 out here. Well, the negative is what reflects about the x-axis, right? So now instead of facing up, we are now going to face downwards. So now we're going to face downwards. We're going to go down like that, okay? That's what this does. Flips it over the x-axis. Okay, now this also the 3, right? The 3 is different from the parent function because there's nothing out here besides a 1, right? So there'd be none, no reflection. You would just say none. Okay, and this is called, when there's a number out here, we take the absolute value of that. So we just get 3. And that tells us whether we have a vertical transformation or vertical transformation, sorry. So that is a vertical transformation. It might say like stretch, a vertical stretch. Cool stretch. A vertical stretch of 3. Okay. This one would have just a 1 out front, so that would be no, none. Trying to think what else it might call this. So then to graph this, we could just plug in a different number, and to see how much, like, because if it was 3, it might look something like that. It kind of grows like that. Okay, so we can plug in a different number besides 1, and I would just recommend plugging in 1 from this 1 over, left or right, usually to the right, sometimes to the left. So if I plug in 0, I plug in 0 into this. I get 0 plus 1 is 1. Square root of 1 is just 1. Times by -3 would get me -3. -3 plus 2 is -1. So I plugged in 0 and I got -1. So I have this point right here. So it looks more like that. So it's kind of stretched out. It's got that vertical stretch to it. And that is the absolute value of your A in front of here. Sometimes that is called amplitude. I believe the homework calls it dilation. They call it dilation. So this one would have dilation none. This one would have a dilation, dilation of 3, where this one would be none. Okay. And you don't worry about the negative. The negative is just going to reflect about the x-axis.